about software development engineer role and what it means to be a software development engineer at Amazon. First and foremost thing, which I want all of you here to really understand and get is, as much as you need Amazon, we need you even more than that, right? We are in search of great talent. If you see the number of problem areas that we are trying to solve, from e-commerce to Prime Video to payments to whatnot, Alexa, AWS, right? We are trying to find great talent which is going to take us ahead in this journey, right? Which are going to be problem solvers. So software development engineer is a first step towards that. And if you read the slide, the first line which says is we're looking for excellent problem solvers and analytical thinkers. Right? We're looking for people who really understand the problem and have what it takes for them to solve it. Not necessarily that's going to be the best solution, but an attempt to solve it. The next one, if you see, we're looking at people who are experts in relevant technical skills, having design, coding, operational excellence, everything in that software development life cycle, which is important, right? And needless to say, we are one of those companies which are strongly focused on customers. And that's one of our leadership principles as well, which we call customer obsession. So we want people to join us who believe themselves to be leaders and take pride in solving customer problems, right? Take pride in innovating on behalf of the customer. So that's what a software development engineer at Amazon encompasses. If you notice, there's one thing which is there. We haven't called out which language that you need to code or which technology you need to be an expert in. That's the beauty of a software development engineer at Amazon, but because we believe that it's not the language that matters, it's not the technology that matters, but it is the way you solve it. And we are looking at problem solvers. The coding, operational excellence, these are all mediums to check what you've done, but need not be that, hey, I know this is a popular question, which is going to definitely come at the end. I am a C++ coder. Can I still apply, or does it need to be Java? No. We are not looking at any particular coder or a language. We're looking at problem solvers. You can be coding at any language. We are more than happy to have you here, right? So that's why our job role says it's a software development engineer and not a particular language coder. Right? So that's what an SDE at Amazon is. Right. The three aspects: design, coding, operational excellence is pretty important. Design, it's not, we're not expecting you to have HLD or like a high level design, because we know that at the level that you would be coming in, the design is required more at a low level end. So it does not matter if you do not have high level design experience. Coding, like I said, any language. Operational excellence, you should know what it means to run code. Right? What it means to debug code. You should know what it means to maintain a code. Operational excellence is nothing but an ability for you to debug code, understand the code, and able to fix bugs. Right? That's what we are basically looking for. Moving to the next slide. Right. So we spoke a little bit of what do we look for. Now let's go a little deeper into it. Right. The first question which we always ask is, will this person innovate and solve right problems for customers? There's a word right there, right? What does it mean? It's basically we're not looking at someone who has so many levels of coding experience, like for example, has gone into competitive coding, HackerRank, and all of that, and has cracked those problems. No, that's definitely add-on, but we're looking at people who can understand what the problem is and understand the right problem for our customers and solve it. There's a slight difference between solving a problem and solving the right problem. We are passionate about solving the right problem for customers. So what are the hard skills that are required, right? For lack of a better word, these are the tech expertise that we're looking at, like a problem solving. Given a problem, how do you solve it? Believe me, there are many ways you could solve the problem. It does not need to be always through code, right? Some problems could be just solved mathematically, but yeah, tell us how you would approach that problem. Are we looking at the perfect solutions? No, we are not looking at perfect solutions. We are looking at your attempt. We are looking at your thought process. We are looking at the ways, multiple ways that you're able to understand a problem and try to give innovative ways to solve it. Coding, like I said, programming languages, any language on earth. If you're comfortable, you should make sure that you're an expert. You get your expertise in that. Like it could be C, C++, Java, Python, whatever. Right? Data structures and algorithms. Yes, this is very important. I'm sure these are courses in your curriculum as well, but we really want you to understand the nuances of data structures. Which is a data structure which is used when, right? Don't just go into the theory of saying that, hey, I know 100 data structures. That doesn't matter, right? What matters is even if you know 5 data structures or even 2 data structures, how in depth do you know them? Do you know when to use an array versus do you know when to use a linked list? Do you know when to use a stack? Right? That's the level of depth that we are looking at. We are not looking at the breadth that you brag about that I know 100 data structures. Doesn't matter, right? You might know 2 or 3, but go deeper into it. Algorithms, right? This is fundamental to solving any problem. What are the ways that you can solve the problem is what is an algorithm, right? The steps of the process. Make sure you get your expertise into it, right? There are multiple algorithms that are there. You could Google around, you could look at, hey, Amazon interview algorithms, you'll find plenty, right? Just pick a few, understand the basics of it, right? Like, for example, if you're looking at sorting algorithms, go deeper. Which sorting algorithm is used when? Just knowing the algorithms won't help, right? That's why, again, stressing on the word right problems. You want to use what algorithm would you use to solve the right problem is what is all about algorithms. Computer fundamentals. This is very, very important, right? This is about operating systems. This is about memory management. This is about how processes work. Make sure you get a little deeper into computer fundamentals and understand. Again, this is a curriculum in your engineering courses. So please make sure that you focus on the fundamentals. We are not looking at any level 2, level 3 kind of computer fundamentals. We're looking at basic fundamentals, but solid depth and understanding of those fundamentals. Like I always say, you might know 5 things only, but make sure you know those 5 things really, really well. That's more important than knowing 100 things and getting confused amongst yourself, right? Make sure you do that. Soft skills, right? You all know that this is solving such large problems. Look at the scale of problems we are solving. All right. There's a problem we are solving, which is like million transaction in a second. We launch a new product on Amazon.in, and there are like 1 million of buyers trying to buy at the same time. How do you solve that problem? This is not one person can solve it. Our company has grown and we've been able to do because of the team that we have. And for a strong team, all of this becomes important, these soft skills like leadership qualities. Amazon leadership principles are something that we breathe day in, day out, right? We use it very often. We use it in all our decision-making process. You could just Google around Amazon leadership principles and you will find them. Have a read at them, right? And the beauty of it is it's not just used within our companies as only, but you could use it in your personal lives as well, right? Go through it, understand what those leadership qualities are, leadership principles are, and make sure that you have some examples around it. You must have all done it, have some examples around it, right? That will make the discussion in your interviews even better, right? I'll give you a small example. We have a leadership principle called bias for action. What does that mean? That means is speed matters in business, and many a times we would have multiple options to solve a problem, but there are times when we would take a gut and we will move ahead with that one solution, right? That's where the bias for action comes into the picture. That don't get into analysis paralysis mode. Take one, let's move ahead with whatever confidence levels we have. Those kind of examples, I'm pretty sure you must have, but think about it before you interviews. Make sure you read those leadership principles and come. So that's how I would put it, right? Hard skills or tech expertise, make sure you have good expertise in one of the programming languages. Come prepared with data structures, whatever minimum data structures you know, but know them really, really well, right? It is okay to say that if you are thrown into a question, and it is okay to say that I don't know, rather than trying to fake it up, right? So have limited knowledge, but have in-depth knowledge of those limited data structures. Read the soft skill, read the leadership principles, make sure the discussion is really, really interesting, which leaves a mark, right? Which shows your leadership skills. Like I said in the beginning as well, we are looking for leaders, right? We're looking for leaders who take these organizations and our companies ahead. Amazon is one of those companies where people join as an SDE and very quickly get into bigger roles. The scope of the problem changes, the charter changes, they get into bigger roles very, very quickly, right? And so we want to make sure that while we hire people who are great leaders, just not coders, right? That's something that is very important, and we mean it. Moving to the next slide, Ronan, please. All right. What are the steps that's required, right? This is pretty popular and openly available information, but I'll still go through it. You've got an online assessment, right? And there are a couple of problems that is given to you as part of that online assessment, which you solve it. And then you get into the next one, which is the real functional interviewing steps, right? So again, the same things that we spoke about. You will be checked on your problem solving. You will be given a language to code on. You might have a data structure problem. You might have an algorithm problem, right? And you will be checked on computer fundamentals. Basic stuff, which I said on the previous slide as well, but make sure you're aware that these are the areas that we are looking at. Again, I want to stress this multiple times. All of this is not to panic you. We are not looking at experts in any of these. We are looking at people who know what they know really, really well. So make sure you come prepared for that. Right? Moving to the next slide. Problem solving and coding. So all of these functional competencies, let's go a little deeper. Right? Understand the problem. This is very, very important. If you are into competitive programming, there is a high chance that you read half the question and you assume that, hey, I've solved this in the past, I will give a crack at it. No, please understand the problem. Ask questions, right? Get it clarified. Ask questions. If you think you're not 100% confident about what the problem is, ask questions to the interviewer. The interviewer has the responsibility to answer your questions. Get it clarified. Do not assume. Do not assume that you know this question. Do not assume that, hey, I have solved something similar, let me get on to it immediately. No. Understand the problem. Take time, right? It's not something that you are checked on. Understand the problem. Ask clarifying questions. You won't imagine how many people who were so good, but just that they did not ask questions, clarifying questions, they messed up in their code. Ask questions, right? Until you get enough clarity, right? Attempt to solve it, code it, and optimize it, all right? Again, these 3 steps seem very easy, but it takes a lot of effort to get there, right? Put your best effort to solve it. All right. There are ways how you can solve it. Try to solve it through an algorithm first. Give a pseudocode. All right. Look, imagine and write it how you would want to solve it. Right. The steps, algorithm. Code it. Use whatever language you're good at. Code it, and then optimize it. Right. We don't expect you that in the first go you will give an optimized code both in terms of memory or time. No. Right, we are looking at normal human beings who code many a times by brute force, right? And then through the code that they realize that, hey, this is not optimal. Let me remove a loop. Let me write a small function to do it rather than having to call it explicitly, right? Use that to optimize it, so which is a natural way to do it. Test it. This is very important. This is very important. Please remember. Again, based on my experience, I've seen many engineers do not test their own code, right? So please once you write it, please test it, right? And when I say test it, do not use only the example that's given as an input or output, because many a times that's a trap, right? use your own, you all in ways of testing, right? Like boundary value analysis and stuff like that. Use a different test code base and test it. Do a dry run of your code, right? Um, I will tell you with a lot of assurance that when you do a dry run of your own code, you will find these small bugs, which maybe like say the loop should have been started at I equals to 1, but you, because you are used to starting a loop at I equals to 0, you might just start it there, right? So test it. Use some random numbers, use some boundary value analysis, find out some data, test your code, right? Test your code with one of a best case analysis and scenario, and test your code with a worst case scenario, right? And then repeat this, like once you test it, if you find issues, solve it, and then repeat. Throughout this whole process, right, please make sure you are making this a more like a conversation. Talk to the interviewer, ask questions, make it like a conversation. Ask permission to say that, hey, let me do a dry run of this code. Yeah, I found this issue. Do you want me to fix it? I can go back and fix it, and what's the problem? Right? That's what encompasses the whole problem solving area. Moving on to computer science fundamentals, like I said, computer science fundamentals is very, very important. This is just not to for our interviews, but in general, I would always suggest that you should have strong grasp on these fundamentals. What is why CSF? Because this is what we breathe day in, day out, right? We are all engineers. We want to solve problems. We go and do it. So this is very important. Like you should know what object-oriented programming is. You should know operating systems, how operating systems work, how memory management is done, how thread lock synchronization happens. Right? What is a process? How do you kill a process? What happens when you have real dynamic conflicts happening in the operating system? Understand the basics, right? Understand the basics. Some aspects of it might be theoretical, but understand them really, really well, right? And if you don't know, you don't know, because our operating system is so vast and complex. No one knows, right? No one knows everything about it. But make sure whatever you know it really well, right? How compilation happens, how thread locking happens, right? How do you do systematic locking, right? What is cache? What is a database? How things work, right? What is synchronization? What are the ways of synchronization? Get to know these fundamentals. Again, this is a very, very vast domain. Don't get overwhelmed by that domain. Whatever you know it really well, right? So that's why if you notice in the slide, we've mentioned about threads, logs, synchronization. These things are basics and you should know it. Again, don't get overwhelmed. I know many people get overwhelmed by this whole computer science fundamentals because this encompasses a large area. Don't get overwhelmed. Get your basics right. Okay, moving on. Yeah, these are some techniques which we have over the years tried and tested them, and we've seen that this has helped not only for interviewing, but it has helped us during our programs. It has helped us during our day in, day out life as well, and I wanted to share that. So there's a format called STAR format, which is like a situation, task, action, result. What this means is, if you remember in the previous slide, we spoke about understand the problem, right? Understand the problem. So this is STAR format, which sounds really, really good. We've used it and it works. Like, what is STAR, right? So write down what the S and T is, what the situation was, what the task is. Like, for example, in this example that's given, right? Answer the questions like, where did this occur? When did it happen? Why is it important? I'll give you a good way of how you should approach this. Pick up one of your projects that you have done in your college, right? Again, this is a very popular question, which I'm pretty sure will come in the Q&A. Hey, I have not done any project in college. How do I do it? I am pretty sure you guys have all done projects. So project doesn't mean only which goes up to 6 months or so. If you've solved any problem, you've solved a mathematical problem, or if you have solved a coding problem, or you've solved an algorithmic problem, right? Pull that in. Need not be that it should be a project, right? If it's a project you have done either in an internship or as part of your curriculum, awesome, right? If you don't have those, but you still can pull up a problem that you've tried to solve and try to fit it into this, right? And this is an exercise I would encourage you all to do it today after this session, right? For that problem, project, whatever it is, right? Try to understand where did this occur? You could say that, hey, say for example, you are in your campus and you're trying to build a Uber-like software for your campus, right? So that people can hire cycles, go inside the campus and come back, right? So where did this occur? You should understand where did this occur. You could start writing down and saying that, hey, this occurred in our campus where we saw that there was a need for commute, right? And cycles were the best way to commute, but given people didn't know where the cycles are currently located and stuff like that, so we wanted to make a system so that they could easily locate the cycle and all. The star ST can be easily written here. Where did this occur? When did it happen? It happened 3 years back or 2 years back when I was in my campus, when we realized this. Why is it important? Like I said, you could start writing down that, hey, this is important because one person has to move from one place to another, like they have to go from their hostel to the college, which is far away. Always walking is not an option. Sometimes the classes are on time and you have to rush. And it is very hard to find where the cycle is, where the nearest cycle is. It could be just behind the campus, or behind your hostel, but they don't know. So we wanted to give a way where they can find it. Write that S&T. If you write it, that gives you that clarity. And when you are asked about, you will give an answer with a lot of confidence and assurance, right? Action, right? Answer these questions. What did you do personally own, right? Like, for example, you could say that, hey, I personally own the front end of it, or I personally own the back end of it. We were a team of 3 people. We said that, okay, we will split it into these 3. I will write the back end. I will write the front end. 1 hour, I will write the whole optimization logic. I would write all of the find the cycle logic, or I would do the payments part of it. Understand what you personally own and how did you do it, right? How you did it needs to be really, which language you used, right? Why did you choose that language? Which DB did you use? Why did you choose that DB? There are so many databases available. Why did you choose that? Did you want a SQL database or no SQL database, right? Who else was involved? Again, if you're writing an optimizing logic or optimization logic, like say a short path logic, you cannot do it alone, right? Who else needs to be involved? You need to involve the front-end guys who calls you. So you might say that, hey, I exposed an API. The front-end guys just consumed the data from me. Or the back-end guys just called me and they got a response. So who else was involved? And focus on the R's. Very, very important. We are a data-driven company and we want to know what results achieved, right? Cost savings, revenue generation, how much money you made. Like, these are all examples, not necessarily all fits into for your use case, but this is a starter that you should know what the result was, right? Or what savings that could you make? What revenue generated happened? What is the volume? So you might be asked about this. Hey, how many cycle trips was happening during your day per day? You should know those numbers of your mind, right? Per month, how many cycle trips were happening? What is the definition of one trip, right? What is the minimum distance that each cycle trip was making? Again, I'm just giving you the example, the use case that we spoke about, the cycle like a Uber inside your campus, but you can fit into your use cases. But make sure you know the result, right? What is the percentage change that happened? What is the year on improvement that happened? How much time did you take, implementation time, right? What's the impact on the customer? Did you get feedbacks from people? How did you like it? What's the team about? What's the quality improvements that you made, right? How do you envision this to take it forward? Make sure you have clarity on all of this, right? And for you to have clarity on all of this, this is a very good tool that you could use. Make a table, write all of this down, and that will help you in the interview process. We'll give you that confidence that you know what that interviewer is asking for, and you will have answers ready for those. Okay, this is star format. Like I said, I totally encourage you to go back and use this format for your current projects, use cases, programs, internship projects, whatever it is. Make sure you use them. It's really helpful, really powerful. Write it down, all right? And that will give you a lot of clarity. Now, can you go to the next slide, please?